Hello students and good morning to you all. So today I am doing class for class 12 science. The topic is continuity of a function. So in the last online class also we were doing some problems on continuity of a function. So today we will continue the problems on the same chapter, that is continuity of a function. So same exercise 2A, page number 257, that is from mathematics for class 12 by Sailendra, right? So here the question number 3. So in the last online class we did question number 9, number 2. We did question number 9, question number 2. This is question number 9, that is number 3. So the question is, let f of x is equal to the function f of x, that is the value for f of x is given as sine of a plus 1 into x plus sine x divided by x when x less than 0. So when x is less than 0, the value for f of x is this one, sine of a plus 1 into x plus sine x divided by x. And the value for f of x is equal to c when x exactly equal to 0. And the value for f of x is equal to this one, x plus bx square whole to the power half minus x to the power half divided by bx to the power 3 by 2 when x greater than 0. So if f of x is continuous at x is equal to 0, if f of x is continuous at x is equal to 0, then you have to find out the values of a, b and c. Now in this case, for x less than 0, f of x is equal to this one, and for x greater than 0, f of x is this one. That is, we're using different values of f of x for x greater than 0 and x less than 0. So you should find out the separate right hand limit and left hand limit in this case. Is that clear? So let us write down for right hand limit first. For right hand limit, we can write that at x is equal to 0, that is limit x tends to 0 plus f of x is equal to limit x tends to 0 plus. So what is meant by x tends to 0 plus? X is approaching towards 0 from the right hand side, and on the right of x is equal to 0, all the values of x are greater than 0. So what is the value for f of x when x greater than 0 out here? When x is greater than 0, then the value of f of x is this one. So let us copy it here. So x plus bx square whole to the power half minus x to the power half divided by bx to the power 3 by 2, right? So let us simplify it. You should get the value of this limit. Okay, so how can you evaluate this limit now? So now here x plus bx square, what is common? X is common here, so is equal to limit x tends to 0 plus. Now write down within second bracket what is common here. X is common, within bracket 1 plus bx second bracket close whole to the power half minus x whole to the power half divided by bx to the power 3 by 2. Is it understood now? Let us simplify this expression. First term, this half power is for both x as well as 1 plus bx, right? So which is equal to limit x tends to 0 plus, right? So here you can write x to the power half into 1 plus bx whole to the power half, then minus x to the power half divided by, denominator remains same, bx to the power 3 by 2. It remains as it is, right? Now in the numerator, what is common out there? It is x to the power half, right? So is equal to limit x tends to 0 plus, what is common in the numerator? X to the power half is common. So within second bracket what do we have? 1 plus bx whole to the power half minus 1. This whole divided by bx to the power 3 by 2. So I think you have understood it. So you can simplify this x to the power 3 by 2 and x to the power half. When this x to the power half goes to the denominator, becomes minus half, right? Is equal to limit x tends to 0 plus This is 1 plus bx whole to the power half minus 1 divided by bx to the power, what is the power in this case? It is 3 by 2 minus half. Is that clear to all of you? So I think I've understood it. So let us simplify it further now. So which is equal to limit x tends to 0 plus 1 plus bx whole to the power half minus 1 divided by, now in this case, b into what is x to the power? 3 by 2 minus half, 2 is the LCM, 3 minus 1, 2 by 2 is 1. So it is only bx. So how can you evaluate this limit now? So let us assume 1 plus bx as z. Let z is equal to 1 plus bx. Let us get the value for bx. What is bx is equal to? This is your z minus 1. Let us change the limit now. When x is, suppose x tends to 0 plus means 0. 0 plus only indicates that x is approaching towards 0 from the right hand side. So it is same as x tends to 0, right? So when x is equal to 0, z is equal to 1, isn't it? That means when x tends to 0 plus, so z tends to, this will be 1 plus. 1 plus means z is approaching towards 1 from the right hand side. Is that clear? Or you may write z tends to 1 also. So which is equal to limit z tends to 1 plus, what is 1 plus bx? It is z to the power half minus 1 can be written as 1 to the power half divided by, what is the value for bx out here? It is z minus 1. So this is the standard limit. Now you know the standard limit, I think. You know the formula. Limit x tends to a x to the power n minus a to the power n divided by x minus a, which is equal to n into a to the power n minus 1. Is that clear? You know this formula. That is a standard limit. So compare these two limits. Here z, instead of z there is x, instead of 1 there is a, instead of z there is x, and instead of n there is half, and instead of a there is 1, right? Instead of n there is half. So you can use that formula in this case. So n comes in the front, that is n means half comes in the front. Half into z is replaced by 1 plus means 1. It only indicates that z is approaching towards 1 from the right hand side. So z tends to 1 plus means it is 1. So replace this x or z by 1. Then decrease the power by 1, that is half minus 1. So which is equal to half 1 whole to the power minus half, right? 1 to the power any number is always 1, which is equal to half into 1, which is equal to half. That is the right hand limit is half. So I think you have understood it. So let us write down for left hand limit now. Let us find out the left hand limit. For left hand limit, so how can you write down the left hand limit? Limit x tends to 0 minus f of x, which is equal to limit x tends to 0 minus. What is the meaning of? What is the meaning of x tends to 0 minus? X is approaching towards 0 from the left hand side, and on the left of x is equal to 0, all the values of x are less than 0. So what is the value for f of x when x less than 0? When x is less than 0, f of x value is this one. So write down that one. That is sine of a plus 1 into x plus sine x divided by x, right? So let us evaluate this limit now. So let us evaluate this limit now. So which is equal to limit x tends to 0 minus, right? So now this is the formula sine c plus sine d. You know the formula of sine c plus sine d from trigonometry. That is the chapter in trigonometry, that is transformation of products and sums. What is sine c plus sine d? 2 sine of, what is c plus d out here? C is a plus 1 into x. A plus 1 into x. C plus what is d? That is x divided by 2. Is that clear? That is 2 sine of c plus d by 2 into cos c minus d by 2. What is cos c minus d by 2? C is a plus 1 into x minus x divided by 2. This whole divided by x. So I think you have understood it. So which is equal to 2 is constant, take it outside limit. 2 into limit x tends to 0 minus, you may write 0 only. Okay, so this is sine of within bracket. This is your ax plus x is 2x divided by 2 into cos of within bracket. This will be a into x is ax and x minus x gets cancelled, divided by 2. So whole divided by x, right? So which is equal to 2 into limit x tends to 0 minus, this is x tends to 0 minus sine of, this is your a plus 2 divided by 2 into x. Here x is common and divided by, you should write x out here, and this is cos into ax by 2. Is that clear now? So you should convert it into the form of sin x by x form. Instead of sin x here, it is a plus 2 divided by 2 into x. So this x should be multiplied by a plus 2 by 2. So you multiply it by a plus 2 by 2. But this should be cancelled. So how can you cancel it? So this a plus 2, it should be multiplied by a plus 2 by 2. Is that clear? So here you can cancel this 2 and 2 will be cancelled. Again, this is a plus 2 is constant, take it outside, which is equal to a plus 2 into, so write down limit for this standard form and this expression. Okay, so limit x tends to 0 minus sine of a plus 2 by 2 into x divided by a plus 2 by 2 into x into limit x tends to 0. This is your cos ax by 2. So I think you have understood it. Okay. Now in the next step, what will you do? This is the standard limit. This is also the standard form. Okay. So which is equal to a plus 2 into, this is just like your limit x tends to 0 sin x by x, which is equal to 1 into, what is limit x tends to 0 cos ax by 2? That is cos 0, which is equal to 1. So which is equal to, this is your a plus 2. So we got this left hand limit. Okay, so this is your left hand limit, that is limit x tends to 0 minus f of x. What is this value? It is a plus 2. So I think you have understood it. And this was your right hand limit, which is equal to half. Okay, and the left hand limit here is a plus 2. Now what will you do in the next step? So in the next step, you have to find out the value for f of x when x exactly equal to 0. So now at x is equal to 0, what was the value for x? F of x is equal to c. Now put x is equal to 0, you have f of 0 is equal to c. So I think you have understood it. So at x is equal to 0, the value for f of x is equal to c. So instead of x you put 0, that is f of 0 is equal to c. Okay. Now what will you do in the next step? In the next step, what will you do? In the question it is given that the function f of x is continuous at x is equal to 0. Now it is given that since f of x is continuous at x is equal to 0, therefore you can write down that limit, right hand limit at x is equal to 0 is equal to left hand limit at x is equal to 0 is equal to the value of the function when x exactly equal to 0. That is limit x tends to 0 plus f of x, that is your right hand limit, is equal to limit x tends to 0 minus f of x, left hand limit is equal to f of 0. Is that clear? So or now what is the value for right hand limit? Half. That is your half, which is equal to, what is the value of the left hand limit? What is the value of the left hand limit? It is a plus 2 is equal to, what is the value for f of 0? That is c. Is that clear? Now you have to get the values of a, b and c. So equating first and second, if you equate first and second, a plus 2 is equal to half, you can get the value for a. A is equal to half minus 2, or a is equal, this is 2 2s are 4, minus 4 plus 1 is minus 3 by 2. We got the value for a. Now equating first and last, that is half is equal to c, that is c is equal to 1 upon 2. So we have got the values of a and c. But what is the value for b? What will be the value for b? Here we did not get the value for b in this case, but you have to write here what are the values of b. B may be any real values. B may be any real values except, so in the question it is given that when x greater than 0, f of x is equal to, you can check it, f of x is equal to, when x greater than 0, f of x is equal to x plus bx square whole to the power half minus x to the power half divided by, in the denominator, bx to the power 3 by 2. B is in the denominator, so b cannot be equal to 0, but b may have any values. B may have any real values, okay, except b is equal to 0. So the answer for a, b and c, what are the values of a, b and c? You can write down the answer. A is equal to minus 3 by 2, but b should not be equal to 0, because in the question b was given in the denominator and the denominator cannot be 0. That's why it is written b not equal to 0. B may have any real values, okay, so except 0. So b not equal to 0. And what is the value for c? C is equal to half. So these are the answers. So I think you have understood it. So you can copy it. You can revise it at home. So we'll do the next question now. So now we'll do the next question, that is question number 10. So that the function f of x is equal to within mod sin x plus cos x, that is its value should be always positive, is continuous at x is equal to pi. Okay, so for right hand limit and left hand limit you have to use the same function, that is within mod sin x plus cos x. So no need of getting the right hand limit and left hand limit separately, just find out limit x tends to pi. Okay, so therefore limit x tends to pi f of x, which is equal to limit x tends to pi. You know meaning of x tends to pi? X is approaching towards pi from the right hand side or from the left hand side. Both right hand limit and left hand limit are included out here. So what is the value for f of x in this case? It is within mod sin x plus cos x. So you can put x is equal to pi here. So it is sin pi plus cos pi. So you should know the value for sin pi. What is sin pi? Sin 180 is always 0. You should know it. Sin pi is equal to 0. Cos pi is equal to minus 1. And tan pi is also 0. Right? So here sin pi is 0. What is cos pi? Minus 1, which is equal to within mod minus 1, which is equal to 1. Right? Now at x exactly equal to pi, at x exactly equal to pi, f of x is this one. F of x is equal to within mod sin x plus cos x. So put f of pi here. F of pi is equal to within mod sin pi plus cos pi, or f of pi is equal to within mod sin pi is 0 plus cos pi is minus 1, or f of pi is equal to within mod minus 1, or f of pi is equal to plus 1. So both these are equal, that is right hand limit and left hand limit are included out here, and this is equal to f of pi. That means the given function f of x is continuous at x is equal to pi. So write down, since limit x tends to pi, f of x is equal to f of pi. Therefore the function f of x is continuous at x is equal to pi. So it is proved. So this is quite easy, isn't it? So you can revise it at home. So this is your answer. So we'll do the next question now. So before we do the next question, you should know about the greatest integer function, right? So what do you mean by greatest integer function? Greatest integer function. So what is meant by greatest integer function? So you should know the meaning of this greatest integer function. So greatest integer function is given by f of x is equal to within third bracket x. Within third bracket x means it denotes the greatest integer function. This where this within third bracket x denotes the greatest integer function. Greatest integer function. So what is the meaning of within third bracket x denotes the greatest integer function? What is meant by it? Now suppose f of x is equal to within third bracket x is there, so it will be is equal to x if x is an integer. If x is an integer, whether it is positive or negative, you should write within third bracket x is equal to x if x is an integer. Okay, so suppose if x is not an integer, it may be in terms of decimal like 2.1, 2.2, 2.3, etc., like 3.3, 3.4, 3.5, etc. So in this case, therefore f of x will be equal to the integral value is equal to integral value which is less than x. Integral value which is less than x if x is not an integer. If x is not an integer. Integral value which is just less than. Within third bracket x is equal to x if x is an integer. Your x value integer say you can write that value is equal to x if x is an integer. But if x is not an integer, so what will you write? If x is not an integer, then f of x is equal to, then this within third bracket x will be equal to integral value which is just less than x if x is not an integer. So if x is not an integer, then within third bracket this x or f of x will be equal to integral value which is just less than x. So I'll give you some example here. Suppose if you have f of x is equal to within third bracket 3 is there, so its value will be 3 because here 3 is an integer. So within third bracket 3 is equal to 3. That is, if you have f of x is equal to within third bracket 2 is there, which is equal to 2. Suppose if you have f of x is equal to within third bracket 0, which is equal to 0. If you have f of x is equal to within third bracket minus 1, which is equal to minus 1, because these are all integers. So therefore f of x is equal to within third bracket minus 10, which is equal to minus 10. Is that clear to all of you? So these are all integer. So that will be equal to that integer. That is within third bracket 3 is an integer. So which will be equal to 3. Within third bracket 2 is there. 2 is an integer. So which will be equal to 2. So again within third bracket there is 0. 0 is an integer which is equal to 0. Within third bracket minus 1 is there. Minus 1 is an integer which is equal to minus 1. According to the first condition, if x is an integer, then f of x is equal to within third bracket x is equal to x. Is that clear? If x is an integer. So if x is not an integer, then what will you write here? Therefore f of x is equal to within third bracket x is equal to. So if x is not an integer, then this within third bracket x will be equal to integral value which is just less than x. Integral value which is just less than x. Example. Suppose x is not an integer, right? Suppose if you have f of x is equal to 1.2. What is this value? Can you tell me? You have to write down the integral value which is just less than 1.2. That is 1. Is that clear? Suppose if you have f of x is equal to, suppose if you have 2.9. So which is the integral value of 2.9? Which is just less than 2.9? Which is the integral value which is just less than 2.9? That is 2. Is that clear? F of x is equal to, within third bracket, suppose there is 3.8. What do you write? It is 3. Which is the integral value which is just less than 3.8? That is your 3. Suppose if you have f of x is equal to 1.01. So what will you write? Which is equal to 1. Is that clear? Is that clear to all of you? Suppose if you have f of x is equal to 0.19. So what will you write? Which is the integral value which is just less than 0.19? That is your 0. That is your 0. It's not 1. Is that clear to all of you? Next one is, suppose if you have f of x is equal to minus 0.9, which is equal to, now this is not the integral value. So which is the integer? Which is the integral value which is just less than minus 0.9? Which is just less than minus 0.9? That is your minus 1. Is that clear? Is that clear to all of you? You should write minus 1 here. So next one is f of x is equal to minus 1.1. So by definition, which is the integral value which is just less than minus 1.1? Which is the integral value which is just less than minus 1.1? Like you have, this is your 0, this is your minus 1, this is your minus 2, right? And minus 1.1 lies out here. Minus 1.1 lies out here. So which is the number here which is just less than minus 1.1? Which is the integral value here which is just less than minus 1.1? That is minus 2. So this will be equal to minus 2. Is it clear to all of you? So f of x is equal to, within third bracket, x is equal to, if x is not an integer, then you have to write down the integral value which is just less than x. That is, if you have minus, within third bracket, minus 0.9, this is not the integral value, so this is not an integer, so you should write down the integral value which is just less than minus 0.9. So where does it lie? Minus 0.9. It lies out here, minus 0.9. Is that clear? So which is the number, which is the integral value which is just less than minus 0.9? That is minus 1. So this minus 1 comes out here. Is that clear? So next one is f of x is equal to minus 3.5. So which is the integral value which is just less than minus 3.5? That is your minus 4. Is that clear to all of you? Suppose this is a number line, right? This is your 0, this is 1, this is 2, this is 3, this is 4, and so on. This is your minus 1, this is minus 2, this is your minus 3, this is your minus 4, and so on. जति हामी राइट पट्टि जान्छौं त्यति नम्बर ग्रेटर हुँदै जान्छ, जति लेफ्ट पट्टि जान्छौं त्यति नै के हुन्छ, नम्बर कम्ती 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 एकदमै कम्ती 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 हुँदै जान्छ. That is, among these minus 4 and minus 3, which is less? Minus 4 is less than minus 3, but minus 3 is greater than minus 4. Okay, so minus 3.5, where does it lie? Minus 3.5 lies out here, not this one. Minus 3.5 is less than minus 3, isn't it? Minus 3.5 is less than minus 3, so minus 3.5 lies out here. This is minus 3.5, right? So which is the integral value which is just less than minus 3.5? It is minus 4. So it is minus 4. So I think you have understood it. So f of x is equal to, within third bracket, x is equal to, if x is not an integer, what will you write? Integral value which is just less than x. You have to write down the integral value which is just less than x. Okay, so you can copy it. So now we'll do the question related to this greatest integer function. So I think you have understood it. Okay. So now we'll do the next question, that is question number 11, that is related to greatest integer function. You have to show that the function g of x is equal to x minus, within third bracket x is given, is discontinuous for all integral points. For all integral points, this function g of x is discontinuous. G of x is given as x minus, within third bracket x, where within third bracket x denotes the greatest integer function. Just now I told you about this greatest integer function. So this within third bracket x is equal to x if x is an integer. I told you this one, isn't it? So that is f of x is equal to, within third bracket x is equal to x if x is an integer, right? Just now I told you about this one. Again, f of x is equal to, within mod x, or not within mod, it is within third bracket x, is equal to if x is not an integer. If x is not an integer, then it is equal to the integral value. Then it is equal to the integral value which is just less than x. Just now I told you about this one, isn't it? Like example, let us give some example out here. F of x is equal to, within mod x. Okay, so suppose f of 3 is there, which is equal to 3, because 3 is an integer. So within third bracket 3 is equal to 3. F of 1 is equal to, within third bracket 1 is equal to 1, right? F of 0 is equal to, within third bracket 0 is equal to 0. Or you can write out the example, f of minus 1 is equal to, within third bracket minus 1 is equal to minus 1. These are all integers, right? Next, if you have f of, within bracket 1.2, which is equal to, within third bracket 1.2 is equal to, what is meant by it? You have to write down the integral value which is just less than 1.2, that is your 1. Is that clear? F of 3.9 is equal to, within third bracket 3.9, which is the integral value just less than 3.9. If x is not an integer, then it is equal to the integral value which is just less than x. So which is the integral value which is just less than 3.9? That is your 3. Is that clear to all of you? So f of, within bracket 10.8 is given, suppose, and within third bracket 10.8. What is meant by it? What is its value? Can you tell me what is its value? What is the value here? It is 10. Suppose if you have f of, within bracket minus 0.9. F of, within bracket minus 0.9. This is not an integer, it is a fraction or in decimal. So which is the number just less than minus 0.9? That is your minus 1. If you have f of minus 2.1 is equal to, what is its value? Its value will be, within third bracket minus 0.9, which is equal to minus 1. So within third bracket minus 2.1, what is its value? which is the integral value which is just less than minus 2.1, that is your minus 3, right? So what is meant by f of 10.9, minus 10.9? F of, this is your f of minus 10.9, which is equal to within third bracket minus 10.9. What is it? Which is the number just less than minus 10.9? That is your minus 11. So you can copy it again. You can copy it, or you can pause the video and you can copy all these things. Okay, so these are all the examples of greatest integer function. So I think you have understood what is a greatest integer function. Okay, so copy it. Now we'll do the solution. So I think you have copied it. So now we'll do the solution now. Solution for this question. So again, I explained you about the greatest integer function. Now we'll do the solution, right? So it's solution. So let us do the solution now. You have to show that the function g of x is equal to x minus within third bracket x is discontinuous for all integral points, for all integral values of x. That is, for all integral real values of x, the function g of x is discontinuous, where within third bracket x denotes the greatest integer function. Okay, so here given here is g of x is equal to x minus within third bracket x. Let x is equal to a, where a is any integer. Where a is any integer, because you have to prove that for all integral points or at all integral points you have to show that the function g of x is discontinuous. So let us assume that x is equal to a, where a is any integer. So now let us write limit x tends to a plus. Limit x tends to a plus, that is your right hand limit, right? So let us write down first right hand limit. For right hand limit at x is equal to a, for right hand limit at x is equal to a, how will you write it? Limit x tends to a plus, limit x tends to a plus g of x, which is equal to limit x tends to a plus. What is the value for g of x here? It is given as g of x is equal to, it is given as x minus within third bracket x, right? So which is equal to, so instead of x this is a plus minus within third bracket there is also a plus. So actually x tends to a plus means s is approaching towards a from the right hand side. You can put here a plus a is a only, but what is meant by that is greatest integer function a plus. So let us draw a number line. Suppose this is x exactly equal to a. So x is approaching towards a from the right hand side, that is, this is your a plus, and x is approaching towards a from the left hand side, that is your a minus. So what is meant by a plus out here? So you should write here minus. What do you mean by a plus here? So on the right of x is equal to a, all the values of x on the right of x is equal to a are greater than a. So which is the integer which is less than a plus? Which is the integer which is less than a plus? A plus means all the values of x are greater than a. Which is the integer which is just less than a plus? That is your a, isn't it? So a plus here means a. Is that clear? Is that clear to all of you? So in this case a plus means a. So a minus a is equal to, what is it? It is 0. Is that clear to all of you? So now what is meant by a minus then? So you should know the meaning of within third bracket a minus. A minus means x is approaching towards a. That is, limit x tends to a minus means x is approaching towards a from the left hand side. So a minus means which is the greatest integer, which is just less than a minus. That is a minus 1, isn't it? That is your a minus 1. Is that clear? So here it will be a minus 1 and so on, right? Like that, isn't it? X is equal to a minus 1. So a minus means which is the greatest integer which is just less than a. Which is the greatest integer just less than a. That is your a minus. Because x is approaching towards a from the left hand side. So this is a minus, right? So within third bracket a minus means which is the greatest integer which is just less than a. That is your a minus. Is that clear to all of you? So now I think you have understood it. You can copy it. So now let us write down for left hand limit. So let us write down for left hand limit. For left hand limit, what will you write here? Limit x tends to a minus g of x, which is equal to limit x tends to a minus. You have to use the same function, that is x minus within mod x, which is equal to x tends to a minus means instead of x you write a minus, minus within third bracket, this is your a minus. Okay, so a minus means here a, because x is approaching towards a from the left hand side only, and you can take x is equal to a in this case for the first case. But for the second case, what is meant by within third bracket a minus? Which is the integral value which is just less than a minus, which is just less than a. That is your a minus, isn't it? That is your a minus. So which is equal to a minus into minus plus 1, which is equal to a gets cancels, which is equal to 1. So just now we got right hand limit is equal to 0. This was your right hand limit, isn't it? So I think you have understood it. So next one is at x exactly equal to 0. At x not exactly equal to 0, suppose x is equal to, because we have assumed x is equal to a, isn't it? Suppose at x is equal to a, so f of x is equal to, not f of x, that is g of x is equal to x minus within third bracket x, that is g of a is equal to a minus, this is a. So here a is an integral value, here a is an integral value, isn't it? A is an integral value, right? So here a is an integral value, therefore g of a is equal to a minus, a is a only, a minus a is equal to 0. So in this case you should understand a minus is equal to a minus 1. A minus means which is just less than the integral value of a, which is just less than the integral value of a, isn't it? I told you that. So again I am explaining you this about within third bracket a minus, isn't it? So suppose this is x is equal to a, right? So x is approaching towards a from the right side, this is a plus, this is your a minus. So this a minus means lies out here, a minus means lies out here, which is the integral value which is just less than a, that is your a minus, isn't it? This x tends to a minus means x is approaching towards a from the left hand side, but x not exactly equal to a. So this a minus means which is less than a, but it is not exactly equal to a. A minus means x is less than a. So which is the integral value which is just less than a? That is your a minus 1, isn't it? This will be your a minus 1. So you have to write here a minus means which is equal to a minus 1. Is that clear to all of you? So what is meant by r minus then? What is meant by r minus? It will be your r minus 1. But what will be r plus? What will be your r plus, which is equal to r? Because you have to write down the greatest integer which is less than r plus. You have to write down the greatest integer which is less than r minus. Is that clear? So within third bracket r minus means which is equal to r minus 1, and within third bracket r plus means which is equal to r. So you have to understand it. Is that clear to all of you? So I think you have understood it. So we have got the right hand limit, that is right hand limit is equal to 0, left hand limit is equal to 1, and at x exactly equal to a, what is the value for g of x, which is equal to 0? Are these three equal? No. That means the given function g of x is discontinuous. Is that clear to all of you? So write down, therefore limit x tends to a plus g of x not equal to what? This was 0, and for left hand limit x tends to a minus g of x, this is your left hand limit. So it is not equal to what? It is not equal to what? G of a. It is not equal to g of a. Okay, the right hand limit was 0, left hand limit was 1, and the value of g of x when x exactly equal to a, g of a is equal to 0. So all these are not equal. That is right hand limit not equal to left hand limit, that is right hand limit not equal to left hand limit not equal to g of a. Therefore the function g of x is discontinuous. So you can write down, therefore since a is any real number, since a is any integer, so in this case we have assumed x is equal to a where a is any integer. So therefore you can write the function g of x, the function g of x is discontinuous. The function g of x is discontinuous at all integral points. At all integral points. So it is proved. So I think you have understood it. So you can copy it. We'll do the next question now. So now again we will write down the definition of continuity of a function. So there is another way of writing the definition of continuity of a function. So first of all we will write down the definition, then I will explain you. Okay, the continuity of a function, the function f of x, the function f of x is continuous at x is equal to a. The function f of x is continuous at x is equal to a, where a is a real value, Real value means it is a defined value. It may be 0, it may be positive, it may be negative. Where a is a real value, the function f of x is continuous at x is equal to a, where a is a real value if limit h tends to 0, f of a plus h is equal to f of a. Okay, so limit h tends to 0, f of a plus h means both right hand limit and left hand limit are included in this case. Is that clear to all of you? Both right hand limit and left hand limit are included in this case. So now I'll explain you about this limit h tends to 0, f of a plus h is equal to f of a. What is it actually? Okay, so let us consider a number line here. Suppose if you take here x is equal to a, here we have taken x is equal to a. A is any real number, a may be any real number. So let us take a as 0. Suppose x is equal to 0, and suppose this is x is equal to 1, suppose this is x is equal to 2, and so on, right? And there is x is equal to 3. Okay, and on the left of x is equal to 0, what will you write? X is equal to minus 1, x is equal to minus 2, and so on, x is equal to minus 3. So let us try to understand this number line. If you understand this number line, it will be clear for this definition, then it will be clear for you. Then you will understand what you mean by limit h tends to 0, f of a plus h is equal to f of a. Okay? So let us take x is equal to 0. Okay? Now this point will be 0.1. This point may be 0.2 and so on. And just before x is equal to 1, we have here 0.9. Like that. Okay? And on the left of x is equal to 0, what will you have? This is minus 0.1. This is your minus 0.2. This will be your minus 0.9 and so on. जति हामी राइट पट्टि जान्छौं, जति हामी उतातिर जान्छौं, त्यति नै बेसी नम्बर हुँदै जान्छ. जति लेफ्ट पट्टि जान्छौं, त्यति नै के हुँदै जान्छ? कम्ती हुँदै जान्छ. ठीक छ? अब हामीले यहाँ के ल्यायौं? a is equal to 0 लिँदै छौं. a is equal to 0. Is that clear? We are taking here a is equal to 0. So now 0 plus 0.1, which is equal to कति भयो? 0.1. हैन? So we are approaching to a 0 now. h is tending to a 0. h is tending towards 0 now. Okay? So h is approaching towards 0. That is, all the values of h on the right hand side is 0 here, suppose. So 0 plus 0.1 is equal to 0.1, right? 0 plus 0.01 is also 0.01. We are approaching towards 0, isn't it? We are approaching towards 0 here. So 0.01 lies out here, isn't it? It comes out here, 0.01. Again, you may have 0 plus 0.01, which is equal, you may have 0.001, which is equal to, what is it? 0.001. Again, we are approaching towards 0. अझै तिमीले भन्न सक्छौ 0.0001 पनि त हुन्छ, हैन? So 0 plus 0.0001, which is equal to 0.0001. This is also tending towards 1, isn't it? Sorry, tending towards 0. 0.1 also tending towards 0. Again, there is another point, 0.01, that is 0.01 also tending towards 0. 0.001 again tending towards 0. Again, you can say, अझै तिमीले भन्नु सक्छौ, सर 0.0001 पनि हुन्छ, अझै 1 नजिक नजिक हामी जान्छौं, त 0.0001. Again, तिमीले भन्नु सक्छौ 0.0040 zeros and 1, which is equal to 0.4 zeros and 1. अझै हामी उता जाँदैछौं. कतातिर जाँदैछौं? 0 पट्टि जाँदैछौं. Again, तिमीले भन्नु सक्छौ 0.00. Suppose there are 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. This is also tending towards 0. तिमीले यो पनि त हुन्छ भनेर भन्छौ, हैन? So which is equal to 0. How many zeros? 5, 6, 7, 8, 9. यो अझै 0 भन्दा अझै छेउमा भयो नि त यो. 0.1 भन्दा अझै 0 को छेउमा कुन चाहिँ भयो? 0.9 वटा 0 and 1. त अझै हुन सक्छ. After decimal point there may be 20 zeros and 1. After decimal point there may be 1000 0 and 1. There are infinite number of values in between this 0 and 0.1. Okay? त त्यही कन्फ्युज नहोस् भनेर चाहिँ हामीले के गरेको भन्दाखेरि यो यसको जग्गामा यसको सट्टामा हामी के लिँदै छौं? यसको सट्टामा हामी के लिँदै छौं? h लिँदै छौं. बुझेन यो? So that is यो जुन चाहिँ पोइन्टहरु छ 0.1, 0.01, 0.001 यो सबै लिनुहुँदा हामीले के लिन्छौं? h लिन्छौं. Where h is a very very small positive quantity. Where h is a very very small positive quantity. So in this case we have taken 0 plus h. Where h is a very very small quantity. Where h is a very very small positive quantity. where h is a very small positive quantity. That is, we are approaching towards 0 from the right hand side only. So in this case, we are approaching towards 0 from the right hand side. Okay, so you have understood this one. We are approaching towards 0 from the right hand side. अब यो नम्बरहरुमा कुन चाहिँ लिने त अब जुन चाहिँ लिँदा पनि भयो अब जुन चाहिँ लिँदा हामी यो पनि लिन सक्छौं 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 पोइन्टको पछाडी 20 zeros 1 पनि लिन सक्छौं पोइन्टको पछाडी 1001 पनि लिन सक्छौं त कुन चाहिँ लिन्छौं त्यो कन्फ्युज नहोस् भनेर चाहिँ यसको सट्टामा यो सबैको सट्टामा हामी के लेखेको h लेखेको where h is a very small positive quantity. I think you have understood it. Okay, that is, in this case f of a plus h यो के भन्छ limit h tends to 0 plus. That is, we are approaching towards 0 from the right hand side. We are approaching towards 0 from which side? Right hand side. Okay, so which is limit h tends to 0 plus f of a plus h. So in this case, what is the value for a? A is 0. In this case, what is the value for a? A is 0. In this case, what is the value for a? A is 0. यो 0 चाहिँ एउटा के भयो पर्टिकुलर भ्यालु आइगयो त यो चाहिँ हामीले के को लिमिट गरेको राइट ह्यान्ड लिमिटको मात्र गरेको ठीक छ सो अब हामी लेफ्ट ह्यान्ड लिमिट पटि जाउँ सो आई थिंक यू हैव अंडरस्टूड इट सो यू कैन टेक द स्क्रीनशॉट So now we will do the left hand limit now. So again let us draw this figure number line. Okay, suppose this is x is equal to 0, right? Now we'll do from the left hand side or from the left hand limit. Okay, so this is your x is equal to -1, this is your x is equal to -2. Just now we did h tends to 0. H tends to 0 from the right hand side only. Okay, where h is a very small positive quantity. Now when you come this side, it becomes -0.9. When you come this side, after this x is equal to 0 on the left side, it will be -0.1, it will be -0.2 and so on. When we approach towards 0, so this means x tends to 0, isn't it? So now we have -0.1 out here, which is equal to, so x is equal to 0 is here, 0 minus 0.1 is -0.1, isn't it? You can write it as 0 plus within bracket -0.1. Is that clear? So we are approaching towards 0 from the left hand side, right? Again you may have -0.01. Again we are approaching towards 0. -0.01 is greater than -0.1. Okay, -0.01 is greater than -0.1. You know that this 0.1 is greater than 0.01. If you write down the negative sign, -0.1 -0.01, if you write down the negative sign, this greater than becomes less than. That is, -0.01 is greater than -0.1. Is that understood? You बुझ्नु पर्छ है तिमीले. So is equal to, you can write here 0 minus 0.01, or you may write 0 plus within bracket -0.01. Is that clear to all of you? Next, you may have -0.001, which is equal to 0 minus 0.001, which is equal to this one, or you may write 0 plus within bracket -0.0001. So you -0.1 छ, यो -0.001 छ. Again we are approaching towards 0. अझै हामी 0 पटि नै जाँदैछौँ. अझै हामी 0 मा नै अप्रोच गर्दैछौँ. ठीक छ? So you may have -0.90 and 1 is equal to 0 minus 0. Suppose there are 9 zeros. Okay, 1 2 3 4 5 6 7 8 9, which is equal to 0 minus 0.90, 1 2 3 4 5 6 7 8 9 1, which can be written as 0 plus within bracket minus 0.2 3 4 5 6 7 8 9 1 2 3 4 5 6 7 8 9 1. Okay, now we are approaching towards 0. Actually we are approaching towards 0 from which side? From the left hand side. So you may have 0 plus within bracket minus 0.1000 zeros and 1. Again we are approaching towards 0. There are infinite number of points like this. So तिमीहरु कन्फ्युज नहोस् भनेर चाहिँ यसलाई हामी के लिन्छौं? फेरि यसलाई हामी के लिन्छौं? यसलाई हामी के लिन्छौं? h भनेर लिन्छौं. Where h is a very small negative number. Where h is a very small negative number. That is, in this case we are doing this one, that is limit h tends to 0 minus f of, here we have put the particular value x is equal to 0. It is 0 plus h. So this is your left hand limit. Is that clear to all of you? So this is for when x is exactly equal to 0. Okay, so let us do next one. Suppose if you have x is equal to 1. Suppose if you have x is equal, suppose it is 2, right? This will be x is equal to 3. This will be x is equal to 1, right? So now let us write down here. It may be 1.1, it may be 1.2, it may be 1.9, like that. It may be 2.1, it may be 2.2, and so on, right? So x is approaching towards 2 plus. X is approaching towards 2 plus means x is approaching towards 2 from the right hand side. Okay, now this is 2.1. So 2.1 is there. So 2 plus 0.1, you can write it like this, isn't it? You may have, before this 2.1, you may have 2.01. 2.01 means again we are approaching towards 2, which is equal to 2 plus 0.01. Is that clear? Again you may have 2.001, which is equal to 2 plus 0.001. Or you may have 2.90s, 3 4 5 6 7 8 9, like that. 3 4 5 6 7 8 9 and 1, which is equal to 2 plus 0.1 2 3 4 5 6 7 8 9 and 1. So we are approaching towards 2, isn't it? Jati basi minus 0 0 0 0 0 0 0 bha त्यति नै हामी we are tending towards 0 from the right hand side in this case. Is that clear to all of you? So अझै तिमीले भन्नु सक्छौ सर point को पछाडी 1000 zeros पनि हुन सक्छ. Point को पछाडी 1 crore 0 and 1 पनि हुन सक्छ. त्यसैकारण हामी कन्फ्युज नहोस् भनेर चाहिँ यसको सट्टामा चाहिँ हामीले के लिएको हो? We are writing h out here. So in this case limit h tends to 0 plus f of, instead of a what do we have? 2 plus h. The a को जग्गामा हामीले पर्टिकुलर भ्यालु एउटा के ल्याउँ? 2 ल्याउँ. बुझ्दैछ सबैले बुझ्दै होला यो? I think you have understood it. Okay, so now we are approaching towards 2 from which side? From which side? From the right hand side. Now let us do from left hand side. We are approaching 2 now from the left hand side. Okay, so let us do that one. So you can take the screenshot here. So I think you have understood it. So here h is a very small positive quantity. So here h भने के हुन सक्छ? 0.1 पनि हुन सक्छ, 0.01 पनि हुन सक्छ, 0.001 पनि हुन सक्छ, 0.90s and 1 पनि हुन सक्छ. Point को पछाडी 1000 zeros and 1 पनि हुन सक्छ. अझै point को पछाडी 1 crore 0 and 1 पनि हुन सक्छ. So you may have infinite values of h. So we can take these numbers as h. Okay, so here h tends to 0 from the right hand side. So that's why we will write here h tends to 0 plus f of 2 plus h. So instead of 2 you may write a also. Okay, so let us approach 2 from the left hand side now. Okay, so I think you have taken the screenshot out here. So now अब हामी के गर्छौं x tends to 2 minus the 1.9 we are approaching towards 2, right? 1.9. So how will you write it in terms of 2 minus 1.9 minus what do we get? This is 1 0, that is 2 minus 0.1. 2 minus 0.1 will be 1.9, isn't it? Is that clear? So which is equal to 2 plus within bracket minus 0.1. Is that clear to all of you? So next one, you may have 1.99 also. अझै हामी उता गयौं, अझै हामी राइट पटि जाँदैछौं, x tends to towards x is equal to 2 पटि नै जाँदैछौं. We are approaching towards 2, isn't it? So we can write here 2 minus 0.01, which is equal to, if you subtract it, you'll get 1.99, isn't it? Is that clear to all of you? 2 minus 0.01 गर्दा कति हुन्छ? This is 9 1 10 9.1. Okay, so 1.99 means 2 minus 0.01, that is 2 plus within bracket minus 0.01. Is that clear? You may have 1.999. Again we are approaching towards 2. We are approaching towards 2, isn't it? 1.999 means we are approaching towards 2, which is equal to 2 minus 0.001, which is equal to 2 plus within bracket minus 0.001. Is that clear to all of you? त तिमीले भन्छौ सर यहाँ अझै माइनस 0.301 पनि त हुन्छ भने भन्नु सक्छ नि त हैन? यहाँ अझै 1.9999 पनि हुन सक्छ. We are approaching towards 2. 1.49 भनेको we are approaching towards 2. So it is 2 minus 0.3001, which is equal to 2 plus within bracket minus 0.3001, like that. Okay, dot dot dot. Or you may have 1.2 3 4 5 6 7. Suppose after decimal point there are 7 nines, which is equal to 2 minus 0.1 2 3 4 5 6 and 1, right? So which is equal to 2 plus within bracket minus 0. How many zeros? 1 2 3 4 5 6 and 1. बुझ्यो? तिमीले भन्नु सक्छ फेरि सर 1 point को पछाडी 10 वटा 9 पनि त हुन सक्छ भनेपछि यो पनि हाम्रो बढ्दै जान्छ त्यतिबेला हैन? त्यही कारणले गर्दा यो टर्म्सलाई चाहिँ हामीले के लिएको हो? यो टर्म्सलाई चाहिँ हामीले के लिएको हो? h लिएको हो. हामीले के लिएको हो? h. So in this case h is a very very small negative number, where h is a very very small negative number. त यसमा चाहिँ हामी कसरी लेख्छौं? यसलाई चाहिँ limit h tends to 0 minus f of 2 plus h. Is that clear? अनि यो h tends to 0 plus र h tends to 0 minus लाई त यसमा चाहिँ हामीले कसरी लेख्छौं अरे? h tends to 0 minus, because we are approaching towards 2 from the left hand side. We are approaching towards 2 from which side? Left hand side. So this is your left hand limit. त h tends to 0 plus र h tends to 0 minus लाई कम्बाइन गरेर चाहिँ हामीले के लेखेको हो? Limit h tends to 0 f of a plus h. यो a भने कुनै पनि नम्बर हुन सक्छ, 0 पनि हुन सक्छ, 1 पनि हुन सक्छ, 2 पनि हुन्छ, etc. ठीक छ? So this is another way of writing the definition of continuity of a function. The function f of x is said to be continuous at x is equal to a, where a is a real value if limit h tends to 0 f of a plus h is equal to f of a. Is that clear now? त यसैमा तिमीको के आयो? राइट ह्यान्ड लिमिट पनि आयो, लेफ्ट ह्यान्ड लिमिट पनि आयो. त यो जुन चाहिँ लेफ्ट ह्यान्ड साइड छ यसैमा तिमीको राइट ह्यान्ड लिमिट पनि भयो, लेफ्ट ह्यान्ड लिमिट पनि भयो. That is, right hand limit is equal to left hand limit is equal to f of a. That is the value of the function f of x when x exactly equal to a. So I think you have understood the definition of continuity of the function f of x at x is equal to a. So this is another way of writing the definition of continuity of a function. So you can copy it now. So you can copy this definition of continuity of a function. Okay, so now we'll do a theorem now. So now we'll do this theorem or question. Let f of within bracket x plus y is equal to f of x plus f of y for all real x and y. Here x and y are the real values. That means defined values. Okay. Now if f of x is continuous at x is equal to 0, so that it is continuous for all real values of x. You have to prove that this f of x is continuous for all real values of x. So what is given here? Given here is f of x plus y is equal to f of x plus f of y. It is given. Okay. For all real values of x and y. That is, x and y are the defined values. If f of x is continuous at x is equal to 0, you have to show that this function of f of x is continuous for all real values of x. So what is given here? Since f of x is continuous at x is equal to 0, what can you write? Since f of x is continuous, so this is your solution, right? Since f of x is continuous at x is equal to 0, so what do we write? Limit x tends to 0 f of x. Both right hand limit and left hand limit are included out here. Okay, so which is equal to the value of the function f of x when x exactly equal to 0. Is that clear to all of you? So let us mark it as number 1. Now again it is given that f of x plus y is equal to f of x plus f of y. So let us put, let x is equal to y is equal to 0. That is, f of 0 plus 0 is equal to f of 0 plus f of 0. Or this is your f of 0 is equal to f of 0 plus f of 0. One of these f of 0 will be cancelled, which is f of 0 is equal to 0. So we can put the value for f of 0 which is equal to 0 in number 1. So therefore limit x tends to 0, f of x is equal to, what is the value for f of 0 in this case? It is 0. So limit x tends to 0, f of x is equal to 0. So let us assume let x is equal to h. So therefore limit h tends to 0, f of h is equal to what? This is also 0. Now we have to prove that this f of x is continuous for all real values of x. Let us take the value of x as a. Let x is equal to a, where a is a real number. Where a is a real number. Is that clear? Now we have to prove that this function f of x is continuous at x is equal to 0, where a is any real value. Where a is any real value including positive number and negative number and including 0. Okay. So now let us put in, suppose let x is equal to a and y is equal to h. So what do we get out here? What do we get? Therefore f of x plus h is equal to, this is y. Given, this is given, isn't it? That is what is given out here. F of x plus y is equal to f of x plus f of y plus f of y. Let us put x is equal to a, f of a y is h is equal to f of a plus f of h. Is that clear to all of you? I think you have understood it. So let us take f of a to the left hand side. That is f of a plus h minus f of a is equal to f of h. Now in order to prove the continuity at x is equal to 0 or x is equal to a, because in this case you have to prove that f of x is continuous for all x, and we have taken x is equal to a, where a is any real number. Let us take limit x tends to a on both the sides. Okay. So let us write here limit x tends to a. limit x tends to a. So it is limit x tends to a, f of a plus h minus f of a, sorry, limit h tends to 0. I think you have to take limit h tends to 0. Limit h tends to 0. Okay, you have to take limit h tends to 0, right? Limit h tends to 0. In this case, you can't take limit x tends to a, but you have to take limit h tends to 0. So limit h tends to 0, f of a plus h minus f of a is equal to limit h tends to 0, f of h, right? So now, since this f of a is free from h, so for f of a you don't have to write down the limit. Therefore, limit h tends to 0, f of a plus h minus, this is your f of a, which is equal to, so now let us mark it as number 2. So limit h tends to 0, f of h is equal to 0. In this case, you can put 0 out here. So minus f of a, take it to the right hand side, or this will be limit h tends to 0, f of a plus h is equal to f of a. So this is the definition of continuity of a function at x is equal to a. Since we have proved that limit h tends to 0, f of a plus h is equal to f of a. So after we got this expression, that is f of a plus h minus f of a is equal to f of h, take limit h tends to 0 on both the sides. So we are taking limit h tends to 0 on both the sides. Since this f of a is free from h, you don't have to write down the limit out here. It becomes f of a. So since h is out here, so you have to write down the limit out here. Limit h tends to 0, f of a plus h is equal to, in this case also you have to write down limit h tends to 0, f of h. What is this value? It is 0 from 2. So we have written 0 out here. Okay, so minus f of a is taken to the right hand side. So this relation shows that from the definition we can write down that the function f of x is continuous at x is equal to a. Therefore, the function f of x is continuous at x is equal to a. Now since a is any real number, isn't it? So here you write, since a is any real number, therefore the function f of x, is continuous for all real values of x. For all real values of x. So it is proved. So I think you have understood this theorem. So this is very, very important. So in order to prove this theorem, first of all, you should know the definition of continuity of a function, which I just explained you. Okay. Then you revise this theorem at home, so it will be understood. So you can understand it. Okay. So revise all the problems that we did today. So we have finished this continuity. So in the next class, we'll do differentiability of a function. Okay. So whether the given function is differentiable or not, we'll check in that online class. Okay. So this much is for today.